Welcome learners for the lecture 6 of a differential geometry. Okay, let us go started as a next topic, that is a curves on the surface. Okay, let will be considering as a r equals to r uv be the equations of a surface of a class r, where u and v is considering as the representation of a domain, that is a in uv plane. Let u equals to ut and v equals to vt be the curve on the class S lying to the domain of the D of the considering to the value. Now consider r equals to r ut vt. Then r gives the position of the vectors point to points in the term of a single parameter. So that r equals to r ut and vt will be generated as a curve lying to the position on the surface of the smallest of a r and s. The equation u equals to ut and v equals to vt generated to the form, that is a v equals to vt, are called as the curvilinear equations of the surface of the plane. Okay, this is the definition we'll be considering, that is a curve on the surface. Let r generated to the value in the both of this condition, that is a u and v. You know that u and v, the second definition will be generated of the surface, that will be considering to the form generating to the value, that is a UV form. If considering to the parameter t in the both of this condition, u equals to consider ut and v equals to consider n vt. Both of this domain of this condition, first will be definition is considering, that is a global representation only as a xyz. Function will be generated if xyz equals to 0, but this will value will be considering, that is the domain of this form will be generating to the equation that will be considering, that is a u equals to ut and v equals to vt, proper class lying to the domain vt. Okay, uv plane will be considering to the form. Now let r equals to generated r ut and vt, both of this condition is generated. Okay, this is the surface of this form, and the equation u equals to ut and v equals to vt are called as this equation, u equals to ut and v equals to vt. This equation is called as the curvilinear equation of the curve on the surface. Okay, these both of this condition will be generated u and v in the form of the parameter t. Definition first will be considering parametric curve. Let r equals to r uv be the given surface of a class r, and let v equals to c, where c is the arbitrary constant. Then the position vector r equals to r uc is the function of a single parameter t, and hence r equals to r uc represent a curve lying on the surface r equals to r uv. This curve is called as a parametric curve. V is a constant in this form because c is generated as a arbitrary constant. Okay, for every value of c there is a one such curve on a surface, since v equals to c, where c is and the arbitrary constant. We get the system of the parametric curve for the different constant value will be generated, that is a c. In similar manner, if we keep u constant and vary v, we get a system of a parameter curve u equals to constant value will be generated. Okay, this will be the show to the, that is the parametric curve. Since we consider to the ordinary points of the surface, we noted that following properties of the parametric curve will be generated and show to the properties for the considering value in the ordinary points on the surface.